Hello all, in today's videos we are going to code a program that checks if a given number is prime or not. So before that, let's see what is a prime number. So a prime number is a natural number greater than 1 that cannot be formed by multiplying two smaller natural numbers. So 5, for example, can be obtained only for multiplying 1 and 5. However, 6, you can multiply it 2 times 3, which both are smaller than 6, and the multiplication of these two numbers will be 6. So given that, let's start to code our program. So prime numbers. And let's create our class. So our class will be prime, and we want to create our public static void main class as well. And now let's search for our input. So new scanner from our system input. Oops. And let's import this class. So now let's get our integer. So we want to get our next integer, so we just care about integers. And let's store this in a variable. So int number to check equals to that. And yeah, let's create a function to see if this number is prime or not. So let's create this function down here. So we will make it private. So we have to put it as static, since we are going to call it from this method over here. So, and we want to return like a boolean. So boolean check if prime, and we are going to pass it a number. And so for now, let's just return true. So every number will be prime for now. So right now our approach will be creating a loop between all the numbers between 0 and our number to check if any of them can divide our number. So for that we are going to use the module operation. So for those who doesn't know the module operation, so in computing, the module operation finds the remainder after division of one number by another. So, for example, the expression 5 mod 2, mod is basically the abbreviation of modulo, will evaluate to 1, because if you divide 5 by 2, it will remain 1. But in the case of 9 modules 3, it will be evaluated to 0, because the division of 9 by 3 has a quotient of 3 and leaves the remainder of 0. So that's why we are going to use this operator to check in our program. So first of all, let's start for writing a loop. So, and we want to initiate it with 2, because our I, if it starts by 1 or by 0, so 0 will not be dividing our number, but 1 will divide our number all the times. But that's part of the prime numbers. So we will start with the 2. We will check for the number, and we will do it I++. So, and now we are going to check if our number is divided by our iterator, and will has a remainder of 0 by doing that. So if this happens, we know that the number divides our number, and basically you know that it's not prime because there is a number that multiplying by another one can get our result, so we will return false in this case. So let's store this result in a variable. So boolean is prime equals to check if prime of our number to check. So, and now let's see the result of our function so far. So is number to check a prime number. So system.out.print and we will print the result of our function, which is prime. So let's see if this works or not. So our examples were using like 5 and 6. So let's start with 5. 5 should have a result of is prime true. So it is true. And now let's see if 6 says false. Yeah, it says false. So you could also improve this loop method so to be in a better performance by only comparing till the half of this number, because you know, if you, for example, you have 7, for example, because 7 is a prime. So 7, the half of this number is so 3.5, but in Java the integers can only store the natural number, so it will be only 3. So, and if you basically multiply 3 by 2, it will be 6. But if you multiply 4 by 2, it will be 8. So this means that if you already pass the middle part, it can only obtain your number by multiplying 2, because it's the smaller number, natural number, that can be multiplied till you get the number that you desire. So, but if you pass the middle, every time that you try to times the number by 2, it will already pass the number that you are passing to the function. So that's why you can basically cut it in a half. So, and to prove that it's basically gives the same result, you can basically say, okay, is 5 a prime number, and says true. And for example 6, basically it's false anyway. So, and in case of 7, that it's what we were testing now, so 7 is still a prime number. So I hope you enjoyed this explanation and our program coding, and hope to see you in the next time. Bye.